The topic of today's talk is going to be modernizing your applications, trying to transform and move away from some of these more monolithic legacy applications that I think also create some of that technical debt, which we're going to get into a little bit today, right? But you know, just as you see, everybody's in a different place, right? And I think probably the top three concerns that I hear when customers say we don't want to move to the cloud yet or we're not ready are: one, we don't know that our applications can work in the cloud, right? Don't know that we would be ready to move, and we don't have the time for a number of reasons, whether it's the pandemic or just other competing priorities. We don't have the time to make that move, right? Another is security, right? People say, oh, well, is my data going to be secure in the cloud? I hear about these breaches. We know that Capital One happened, and we know that Comcast happened, and all these things. It is very secure in the cloud. You just need to make sure that you configure it that way, right? And the last concern I would say is probably around lack of expertise, right? But as Ron was mentioning, that's why you have partners like Logicworks. So today we're going to be talking a little bit about how Logicworks can help you through these things, but it's more so just about the framework itself of how to modernize, how to optimize your applications. We're going to go over technical debt, why it's really bad. I know everybody knows what technical debt is because everyone has it. Why you should consider modernizing, why modernizing would actually help your technical debt situation and probably alleviate all three of those concerns that I just mentioned about migrating to the cloud. Then we're going to talk a little bit about how you can modernize and optimize within AWS. Now, even though I'm talking about AWS, these are, again, framework best practices that are applicable to GCP or Azure or IBM or Alibaba. You know, doesn't matter where you are. It's more so the ideology, the methodology of migrating and modernizing, right? Next, we're going to look at a few fundamental principles, how we actually maintain best practices within the well-architected framework, right? And then I'm going to give you some examples in a case study, right? Before we get into that, just a little bit about myself and about Logicworks. My name is Donovan Brady. I'm the Director of Solutions Architecture at Logicworks. Been there since about 2014. I'm from New York. I've been a professional musician since I was a little kid, and I am a super 90s gamer nerd. I play 90s video games pretty much exclusively, except for Elden Ring that just came out like 2 weeks ago, and I've been playing that nonstop. So I see a few head nods. Good game. Logicworks is a leader in the Gartner Magic Quadrant for cloud managed services and professional services. So as Ron mentioned, we help hyper-compliant customers, those mission-critical 100% uptime applications, whether you're a SaaS platform that works with financial services or health tech companies, or if you're the actual financial services firms or healthcare companies, the hospitals, the medical practices, those things. As you can see, some of our clients tie in directly with that. Orion Health, the largest e-health platform, right? Nextgate, similarly, wealth management systems, they migrate 401ks, that kind of stuff, right? All right, so let's talk a little bit about technical debt. Well, like I said, we already know what technical debt is, but to just quickly reiterate, it's the accrual of complications in your application due to the reliance on a specific piece of technology, a specific software, or a dependency or a methodology that you leveraged, right? Let's say we built this application 10 years ago and we built it with the latest and greatest at the time, or maybe it wasn't the latest and greatest at the time, but now fast forward 10 years, you never really went back to refactor that or get it out of that dependency, right? It causes a lot of strain on the application and causes some complications when you try to integrate that with other systems, right? It usually comes because of over-engineering. You try to plan for the future, you try to future-proof it, then you end up creating this giant monolithic discombobulated mess. You know, we've always been there. And it also leads to a lack of coding standards, right? We want to make sure that all of our engineers can code on the same best practices. They're all leveraging the same tools, the same methodologies. technical debt when you're going in a bunch of different directions and you have to maintain reliance and dependence on something from 10 years ago. It's much harder. As you can see, there's an inversely proportionate correlation between the time that's available for new projects and the time that you are spending actually trying to get rid of this technical debt, right? So as you try to spend more time getting rid of the tech debt, you have no time for new projects. And that's fortunately and unfortunately why Logicworks is in business, because that's when people call us and they're like, hey, we need help because we don't have the time ourselves. Why is it so time intensive? Well, like I just said, there's a million different things that are a part of this, right? There's the infrastructure itself that you need to be cognizant of, right? Oh, we're actually running Windows 2008, right? Windows 2008 is end of life. It's got all these security concerns. We can't patch it, so now we have to spend all this time. The newer technologies aren't even compatible with Windows 2008, right? So have to deal with that. And then you have to actually deal with the applications themselves and the libraries and the modules. You can't move to Python 3, for example, because you're stuck on Python 2, right? So a ton of issues with that. It creates clunky monolithic legacy applications that are really hard to manage, long story short, right? They're not very reliable. Usually there's stateful architectures. You can't deploy them in multiple availability zones. You can't have them redundant. So it creates a single point of failure pretty much everywhere. They become very costly. They're slow and inefficient. If one thing breaks, then everything else breaks. So everything has to be moved through this giant long process of this monolithic legacy thing. And they're static. They're not very changing. Now, staticness, is there a word for that? Whatever. Staticness is kind of the biggest problem for a tech company or for any IT team. And that's because you can't innovate, right? We have all these business priorities. You have your board, you have your directors. They're all like, you need to innovate and you need to go better, faster time to market, build all these amazing things. And then you're like, well, we can't really do that stuff because we're static. We've got this application that's 10 years old, right? So how do we fix it? Tech debt stinks. Legacy monolithic applications stink. What do we do? Well, you can fight this zombie of tech debt with modernizing and optimizing your applications by refactoring, right? What is refactoring? Refactoring is when you actually rewrite either a part of the code or all of the code to move away from some of these more monolithic legacy terms or methodologies and more into a microservice-based decoupled architecture, right? We're going to get into a few of these different decoupled architectures and methodologies in a little bit, but it's really positive for your business as it promotes growth. Like I said, it enables faster time to market, and it enables better, less static architectures, right? More innovation. So you spend a lot more time up front. You have to re-architect your whole application. You need to refactor the application. But the time spent managing the application, as you see here, would be like that, because you're not managing the complex stuff. You have all this time for new products, right? Okay. It decouples your dependencies, allowing for greater flexibility and agility for your teams. You can focus on your business requirements, on whatever your board and the directors, like I was mentioning before, are telling you that you need to accomplish, right? And finally, you can leverage cloud native tools. One of the biggest benefits of the cloud is that, you know, we're all a pretty big company. Actually, Logicworks not a pretty big company, but Porsche, Equifax, right? We got thousands of employees, thousands of engineers, but I don't think you have as many engineers as Amazon or as Microsoft or as Google, right? And they have engineers, thousands and thousands and thousands working around the clock to create amazing new technologies like Anthos, as we heard about before, right? That are cloud native solutions. But if your application is too legacy or too monolithic, you might not be able to leverage some of these. And leveraging these cloud native tools is really the key to unlocking the capabilities and the capacity of the cloud, right? Because you can offload a lot of that hard work that your team would be doing, managing and deploying and building these applications onto the cloud providers, right? PCI, for example, let's just talk about compliance. If I don't have to worry about processing payments and transactions and storing all that stuff and managing the operating systems of the VMs, then I could just be like, hey, Amazon's doing it with serverless Lambda functions. That's it. That's my whole audit. And like, okay, it's done because Amazon has it, and Amazon goes through their audits. But if you can't leverage Lambda, for example, then you do have to show your evidence for all of these different components and how am I managing the operating system and access and authentication and encryption, right? So AWS promotes modernization, not just the AWS, again, the other clouds as well. But as I mentioned with these cloud native services, as you can see, these are all microservice-based serverless applications. You probably can't read them, but just to name a few, we've got things like API Gateway, right? SNS, SES, right? If you ever need to send a text message or an email or a notification or alert to any of your customers or clients, right? All of that is done via a serverless backend, right? If you needed to expose your data via an API, you don't need to host it on a virtual machine that's monolithic with your database, with the API piece, with the front end layer, with the analytics piece. You decouple it and you have the API gateway hosting just the API and your data, right? So a million different tools that are opened up to you if you're able to modernize. Right? Modernization, as I said earlier, allows you to maintain some best practices around the well-architected framework. Now, who's familiar with the well-architected framework? You're from AWS. Come on. Okay, thank you. Wow. Whew. So the well-architected framework, it's 5 pillars. Actually now 6 pillars, believe it or not. It used to be 5 pillars that you see here. There's operational excellence, security, performance, cost optimization, and reliability, right? There's a 6th that just was added, which is sustainability, because we all need to make sure that we're saving the trees and the turtles. No more plastic straws. So the well-architected framework is like 400 pages of white papers that AWS wrote like 10 years ago and have been updating continually every year ever since, with additional lenses. There's like a serverless lens. There's all these different lenses with respect to these best practices. And they are recommended approaches for basically anybody to maintain a well-architected, well-defined architecture in AWS, right? Azure has adopted it, Google's adopted it. Everybody has their own well-architected framework, but the principles are basically, all the same. We want to make sure that we can operate, right? We want to make sure that our management teams are set up for success in terms of monitoring and ongoing management, alerting and triage of tickets, things like that, right? Security, if you have compliance concerns, you want to make sure that your security teams are set up for success. Your logs are being aggregated and analyzed. Reliability, we're redundant. We're deployed in a multi-AZ, multi-regional approach. Do we have a DR strategy? Things like that. And performance and cost optimization. How efficiently are we running, right? Modernizing your application actually goes hand in hand with each of these components of the well-architected framework, right? First and foremost, it allows you to decrease costs because it allows you to decouple some of these things and scale individually with each of the microservices, right? Let's say I have a giant monolithic application that has a giant SQL Server database in it, some .NET front-end web servers, a couple of utility boxes, and Zookeeper. I'm running some streaming services. I've got Kafka in there, right? A million different things, but it's all on one VM, right? If I wanted to scale that, I had a new customer join. I have to scale that. I build an entire new giant VM. That giant VM is going to cost me like $5,000 a month, right? Because it's got all these things, plus the licensing for SQL Server, plus all this stuff, right? But if I decouple those, because really, I don't need the database to scale with the customer. I just need the data footprint to scale. I need the web servers to scale because that's where people are actually accessing, right? So I decouple all of it and I keep a small database and I keep an auto-scaled front-end web server, right? So instead of spending $5,000 per additional server, I'm actually spending like $50 per additional server, right? It allows you to improve your reliability because as these instances scale, they can scale across multiple different availability zones, multiple different regions, right? So you have better reliability across all of your resources and they're more redundant. Obviously, it increases innovation, as I was mentioning before, and flexibility. It allows you to have your engineers focus on more cutting edge, more bleeding edge technologies. You're not dependent on the 20-year-old SQL Server database that you're running. Now we can leverage more cloud native operating systems and databases like Aurora, right? Beautiful Aurora, Postgres, and MySQL, things like that. See some head nods in the back. Thank you very much. And finally, it allows us to decouple these applications, right? Focusing primarily on each one, we can code our business logic into each component of these microservices, rather than having to think of everything at the same time and boil the ocean. We can instead boil a few little creeks along the way. Creeks, ponds. All right. Let's talk about some common modernization architectures. So a lot of people are like, well, I get it. So there's a lot of benefits to modernizing and refactoring, but again, I can't boil the ocean. I can't do everything at the same time. So let's start small and let's work our way up. I'd say immutable based infrastructures are the best entry point into a modernized refactored application. And immutable infrastructures allow us to create CI/CD pipelines and make our infrastructure ephemeral, right? We don't need to manage pets anymore. We don't have long-standing virtual machines with data that's static on the instances with cached data everywhere you look. Now they're ephemeral. I can blow it away and then spin it back up. Again, it increases the agility and flexibility of our engineers because as quickly as they need a resource to try and develop or sandbox, they can spin one up, right? You know that it's ephemeral. You can spin it down if there's ever an issue. If the application doesn't work, you're like, ooh, that didn't work. Patch it, blow it away, spin it back up, right? You know that your security is intact because it's immutable, it's baked, right? So you have these pre-baked functions and security guardrails at the operating system level. You want to make sure that your data is encrypted. You want to make sure that your IDS, IPS solutions, your antivirus, anti-malware, these things are baked into the operating system by default, so that when your developers do actually inevitably go and spin up new resources, you're not so worried that there are security concerns because what you gave them was a golden template for security, right? It allows you to deploy them across multiple different resources, across multiple different regions and accounts. You don't have to worry about managing, again, these pets. You can deploy and leverage them wherever you want, making changes at scale across everything. Instead of having 100 different instances that I need to change configurations at the operating system manually for each one, I can just change the code once and then deploy it across all 100 instances, and boom, it's done, right? I'd say the next step is probably containerization. This is where we get into the Anthos conversation that we heard a little bit earlier. But containerizing allows us to get rid of these operating system level concerns while still running a virtual machine-based architecture, right? So we can containerize the app, not worry about the underlying hardware or architecture. It's not Windows, it's not Linux, it's not SUSE, right? Just learned that that's how you say that. It's Docker, right? And Docker can be deployed anywhere, and it doesn't matter what's underlying. I have some dependencies for Windows, great. That's gonna be running on Linux as well because it's gonna be Dockerized, right? It allows us to scale, again, like these microservice-based deployments. We can put each of these microservice containers in their own container and then scale them individually. I can scale the web server containers. I can scale the utility containers. I can scale the analytics tool, the mail processing servers, whatever your application requires, right? I can scale them individually, again, allowing for greater flexibility and agility. And finally, reliability, right? Containers are also ephemeral by nature, leveraging something like Anthos or AWS EKS or ECS, right? This orchestration tool. If it notices that a container is dead or is not available, it'll automatically replace that. Like it'll rip and replace. It'll say, oh, sorry, this one's not pinging. Get rid of it, deploy a new one. Right? And finally, we have serverless workflows. I've talked a little bit about serverless. Serverless, I'd say, is like the far right end of the spectrum of modernization. It's do away with everything that you know of so far. We're not deploying to virtual machines. We're not deploying to operating systems. We're literally just writing the code. We're writing that Python 3 code and deploying it to Lambda, right? Deploying it to API gateway and step functions and allowing it to just do its thing, right? There's nothing like that in an on-prem world, right? On-prem, you always have to be running in your virtual machines. You have to worry about your vCenter. You have to worry about the virtual machines themselves, the operating systems, your network. So you can imagine why the flexibility and time that I've been talking about would be freed back up, because you really only have to worry about your developers and what they have to do. We've done this for a ton of customers, but one customer that I want to talk about in particular is a company called ServicePro. Pretty well-known company. You've probably seen the big green trucks with the orange house on it, right? ServicePro is a leading fire and water cleanup, like a disaster cleanup company, right? And as you can imagine, they're a national company. They have over 1,700 franchises nationwide, right? And they had PCI requirements because they process payments. 1,700 franchises were all tied into this single monolithic database that was running SQL Server, as I was mentioning before. And they had over like 300 applications on the back end, some back office applications that were also tied into this SQL Server, right? So what did we say? Well, we said there's no possible way that we're going to be able to migrate 300 plus applications and this database without something breaking. Plus, it was built like 15 years ago. You're not going to carry that tech debt over into the cloud when you move there. We're gonna do it right. One of my favorite phrases, my quote, is my own. It makes no sense, but it makes all the sense at the same time. It is, if you're going to move to the cloud, move to the cloud, right? A lot of people are like, oh, well, I'm going to do VMware in the cloud. Look, VMware in the cloud is great, but you're just delaying this technical debt that we've been talking about, right? If we're going to move to the cloud, let's do it. Let's modernize. Let's leverage all the cloud native services and tools, and let's get that agility and flexibility with our applications, right? So what we did for them, we designed a Kubernetes-based containerized application running on AWS EKS. We migrated their SQL Server, that giant SQL Server, over to Aurora, Postgres-based. And they had a DynamoDB, which is the NoSQL database in AWS, for all of their static and cached data. Right? We removed and decoupled the dependencies between these back office applications that I've been mentioning, and we created this CI/CD immutable infrastructure pipeline so that they can migrate each of these backend applications one by one, again, knowing that the image is baked, the security tools are baked in, and they don't have to worry about the security posture or their standards. And is this actually going to be PCI? Because we actually codified everything and made sure that by default, it was all built to PCI standards, right? That's pretty much all I've got for you guys today. I really appreciate everyone coming out and listening to me and my terrible dad jokes. I think we're about to take a break. So thank you and talk to you soon.